So Shinra Technologies is a platform dedicated to what we believe the future of gaming is going to be, which is everything being done in the cloud. Up until now, when we've heard about cloud gaming, what we have typically thought about is a change in distribution channel. You don't have to play on specific hardware. You can play on any device. It's just a video stream. And that's true. It's one of the benefits of what cloud is. But it doesn't actually take advantage of what you have in a data center environment. You have all of these CPUs and GPUs located in a data center. They should be talking to each other. If you properly connect them, you should be able to get something that is much more incredible than you could ever do with a single chip in a box under your television. When we were looking at what cloud gaming had been in previous years, we saw that nobody was really doing that. They were taking a game as is, whether it was a regular PC SKU or something from mobile, and they were encoding it. So that means that they were taking the actual video image that was created by the game and turning it into a video stream and sending it to other devices. And it's like, cool, well now I can play Tomb Raider on a device that wouldn't normally be able to play it, but all that you can get from that is a game experience that's almost as good as what you would be able to normally play on your PC. We were disappointed by this. So a number of years ago, when a lot of these companies first started coming out, they all came to us at Square and they said, well, we'd like to have your content for our system. So we went and we investigated them. And I personally went and did a lot of the business analysis for this. And the end result was we saw two problems with it. One, the cost was tremendously high. It was very expensive to take a game as is and just put it onto a server, because you look at a console whose price is $300 and you look at a server whose price is $3,000, and they were basically running one copy of a game on one server. The second problem was, if you've got all of these systems there and you can parallelize them, which means you can make them talk to each other, why aren't you making new game experiences that actually take advantage of this? Why would you design a game to run in a data center environment the same way that you'd run it in your home? So we wanted to change those two factors, and that thought was about 4 or 5 years ago already. So in the beginning of 2011, myself and Iwasaki-san, who's our SVP of tech, began working on putting together an actual technology and business plan together for a new type of cloud game. He began to develop a new type of architecture. And the benefits of the architecture became apparent very quickly. So in theory, it all worked out very well. We started to do some limited tests. And the limited tests in mid-2011 were very promising. So we put a team together. We began doing development out of Montreal. We actually partnered with Ubisoft for some of this development, which we announced when we announced Project Flare back in late 2012. And we started heading into R&D, real research and development on, can these theories really result in something practical and new? And we exited R&D about a year and a half ago, and we began the process of commercializing the system. Again, assuming that infrastructure would be put in place. And it was about a year ago when we realized that it wasn't being put in place, that somebody had to go step in there and get the hosting providers ready, put the network connections into there, build out the tech into something that developers could really use, and then put the marketing and branding in place. And we decided to do it ourselves. We're not focused on back catalog streaming. We are focused on new game experiences that can only be offered in the cloud. So we look at it as a different space that doesn't compete with other offerings. Microsoft's focus is on making their Xbox One successful. It's a piece of local hardware where they're doing rendering locally on their system. But we're going in a very different direction. We want to do everything on the cloud so that only a video stream comes back. The problem with that is you need to have a good connection. So we're looking at more of a Tesla-like strategy with how we roll out. We don't pretend that it's going to be nationwide and everybody's home in America on day one. We will probably start on a regional basis in places where there's good fiber optic connections, and then over the course of months and eventually years, try to cover the rest of the nation. This is a long-term play.
How long term are we talking here?
We see this as the next step of the industry, the absolute future of where the game industry is going.
Next generation, you think, or even further than that?
Further than that, I mean, this is where everything will inevitably end up. And so the transformation could take 5 to 10 years. But in terms of where we want to get the service in place, we want to hit the coasts in the next year to year and a half, and then connect the rest of America within 2 to 3 years.
People imagine this system like, oh, you might create some custom content that can only be done through the cloud service, but then would those games only be available on the coasts?
So it's a very good question, and I think that the answer is yes. If you've got a game that's run exclusively on the cloud, it's only going to be available at the start for people whose internet connections can handle it. It's not something that we're proud of, but we have a level of quality that, you know, we come from Square Enix as a history who has a very high quality bar for their products, and we want to be able to provide a product that is equally high quality. So at the start, yes, it's going to be limited in terms of who can play it, but we are working as hard as possible to get it to everyone within a reasonable amount of time.
And then is this going to be a subscription service, or how does this whole thing work?
So we're not ready to speak about the service model yet because a lot of pieces are still in place. I'm working actively with partners in the data center space as well as the network space to make this as cost feasible for gamers as possible. And that's all I can say at this time. So in terms of the actual developers creating content, we see 2 major areas that we want to focus on. One is on enhanced content, and one is on truly from the ground up cloud content. And enhanced content is, for example, taking a game that's in a company's pipeline and doing things with it that can only be done in a cloud environment. And if you want an example of that, for example, there's a lot of indie, particularly shooter games that are very difficult to network. You have a synchronization problem, and the synchronization problem is one of the problems that we solve fundamentally with our architecture. You have a server, and you have a lot of game consoles or PCs, etc. And what they're doing is they're sending data of position, of enemy units, of objects back to the server. But as you increase players, you increase this mesh that makes that data much more complicated. So you either need to highly limit the amount of data that you're sending, or you need to limit the amount of players that you're sending, because you have to synchronize that state across all those clients on a millisecond basis. What we are doing is like old school 4-player split screen, but on a massive scale. Everything exists in one local instance on a server, and we just sort of FaceTime that or Skype that individual user screen back to the person. So if an indie, for example, wants to create a multiplayer game, now it's really easy because it's just local co-op that's being streamed back to the user. So one of the games that we have under development that's going to be part of our upcoming beta in Japan, as well as in the United States later next year, is a game called Space Sweeper. And it was created by Kengo Nakajima, who is a very famous indie in Japan. He wrote a number of books on MMO development. His MMO Architecture is the basis of a number of Japanese MMOs. He has had an idea similar to ours for a long time. So in the process of conversation, we said, would you like to try building something for us? And he said, yes, and he was very excited. And so he created a game where there are tens of thousands of moving objects. It's a 2D sprite game, but it's doing something that you normally couldn't do because you couldn't take all of those tens of thousands of objects and fairly synchronize them to multiple clients. So his game has got lots and lots of objects, and you can scale it to 100 users, 1,000 users, all playing on this same one world with all these objects moving together. Because again, it's just GoldenEye or Mario Kart sitting at your home with a split screen, but done to a huge scale. So we have an architecture for indies, which is an SDK that we're looking to release next spring. It's called our virtual MMO architecture, and it's going to make it very easy for indies to create multiplayer games in a way that they hadn't been able to do before. But on the AAA side, we've been working for the last year on a very different type of architecture than any 3D developer has been able to access before. And the idea is, if you've got a lot of memory and a lot of compute and a lot of render power, what kind of world could you create that you couldn't create before? And so we're going to developers and we're saying, what part of the pie did you have to cut out? What kind of game design that you weren't able to do before because of the limitation of processing power on the client can you do now? And if you don't have to worry about synchronization anymore, what else could you do? So the R&D started with, how big of a world could we create? And so we created this world that was 17 times the size of Skyrim. And you can go from one part of the world to the other without ever encountering a loading screen, because the entirety of the world is in memory. We don't have a limitation anymore because we have hundreds of gigabytes of memory on this server. Then from there, we populated with hundreds of thousands of trees and other objects at the same time, tens of thousands of animation that's occurring, because we've got 1,000 plus fully animated characters running around in this world. And then we made it instantly multiplayer, because again, we just connect 4 controllers to it, we output 4 video streams, and then we're done. And so that was the first test. Would it be interesting, would it be possible to create something that people hadn't created before if you give them this much power in the data center? And the next thing that we're going to be doing is taking it to the next step. So introducing massive physics. We've got something like 8 million hard objects in the world right now. Again, all of it interacting at the same time. And then we're doing real-time terrain deformation, which is something that you can almost never see in large multiplayer worlds. Again, it comes back to the problem of synchronization. How can you fairly create a map that is on a particle basis being changed in real time that has to be synchronized in milliseconds between clients in multiple parts of the country? Well, if you don't have to worry about that anymore, if they're all just inputting directly into one very large console, or what we're calling virtual supercomputer, then those problems get solved and you're able to do something people haven't seen before.
So in your announcement, you said that you were partnering with Avalanche. Can you talk about that collaboration at all?
We have been speaking to Avalanche for a long time. They have been a great partner with Square Enix for the Just Cause series. And they are very technologically advanced and forward. On an engineer-to-engineer basis, Shinra and Avalanche had a very good connection. And so over the course of many months of conversation and demos between us and them, they said to us, would you be interested in partnering with us, especially on the office space for now in New York City? Because we were planning to come to New York and we didn't have any place. And knowing what they were working on here in New York City and what we were working on, we saw aspects of collaboration that could be enhanced by being physically located in their studio, just in terms of conversations that we could have. And so we said, yes, we'd love to do it. They very kindly made office space for us when they don't really have any, which said a lot about their interest in wanting to work with our tech. I went out to Sweden to meet with their CEO and executive team at the beginning of September, and we continue to have very good conversations about where to take this in the future.
Okay, so the Avalanche collaboration, does it mean that they're making a separate game that'll harness the power of the cloud somewhere in the Avalanche company, or is it just possible future collaboration with the Just Cause series?
At this time, I want to call it a possible future collaboration with Avalanche Studios. I'm not going to announce any particular title or project.
It would make sense with them getting more and more into systemic destruction to have that all taking place in one location for multiplayer purposes, don't you think?
I think it does make a lot of sense, not only for Avalanche Studios, but any company whose technology links their physics engine with rendering, where it becomes so hard to separate the two of them that multiplayer becomes difficult to guarantee in terms of a fair experience. And what's really interesting is not just doing multiplayer, but enhancing it in such a way that only the power of CPUs and GPUs working together can offer an experience. And what I mean by this is the following. So you've probably seen massive explosions in Just Cause 3. And those explosions are super cool, but you have to calculate it one time for one user. But let's say that you've got a lot of users playing in a single world, and I'm not going to limit this to one particular game series, so any multiplayer game in general. If you've got 10 people playing together, for example, and there's one massive explosion in the world, well, you've got 10 servers working together on this, for example. And so what you can do is you can dedicate an entire server to making one single explosion that occurs in all 10 of those people worlds. So instead of having that explosion 10 times calculated by 10 different computers, you do it once. And the end result is you have a lot more processing power to do it on a particle basis. So that smoke is no longer just an effect that's been pre-calculated depending on the explosion, but that is actually done in real time as a physics simulation on a particle basis. And so smoke is actual smoke particles that are affected by wind that enemy AI actually path traces through, right, on an individual particle level. And you have an entire server dedicated to doing this, so the realistic effect behind this is like something you've never seen before. That's the kind of direction that we want to push into. So we are coming actually from a fundamentally different space and way of thinking about game development, which is massive parallelized systems, supercomputers for gamers.